Hi, Don Emilio here, physics and chemistry teacher for Sec Dublin. I'm going to explain today universal gravitational force. We're going to see it from a very, very interesting point of view, that is the unit of a Newton. Okay, so let's start first with the equation to understand it. We all know that the equation of the universal gravitation, it will be the universal gravitation, it will be gravitational force equals G, that is a constant, is the gravitational constant, okay? And we have mass of the first object multiplied by the mass of the second object, all of it divided by the distance between these two to the square, okay? You can call it R, or you can see it sometimes as a letter D, but it's fine. However, to make it more simple, we need to see this from a perspective of units. Okay, so we see that G is a constant, okay? And the unit of this constant is gonna be Newton meter square over kilogram square. Let's wait for this to write. Very good. Now we have here the unit, okay? This is the unit of the constant of gravitation. Now, the unit of mass, we know the unit of mass. The unit of mass, we all know, is the kilogram, okay? And the unit of distance, in this case, R, is the meter. Okay, so first of all, we have here all the units, perfectly fine. Newton, this is the point. This is where things get interesting. The Newton. What is a Newton? What is a Newton? A Newton, we all know, Newton, okay, let's go over here. Newton is kilogram meter square second. Okay, why is kilogram meter square second? Let's see it. Let's see why. Okay, following the second law of Newton, we have that force equals mass times acceleration. Okay, so now we know, we put it in green. Now we know mass is gonna be kilograms, and let's put it here so we can see it clear. And meter square second is gonna be acceleration. Okay, now pay attention to this form of writing meter square seconds. Okay, meter square second, we all know, following mathematics, that when something is meter square seconds, this is the same as meter over second to the square. In this case, it's the same, it's different expression, so we put the square second in here. So what we're going to do is we're going to follow all this formula, we're going to put it in this way of here. How are we going to do that? Well, let's see. It shouldn't take time, it should be quick. So we have here that G is, as we can follow in this part of here, we can see G is Newton meter square, and then kilogram square, so we can put it kilogram square like this, so we know when it's negative that it goes under. Okay, as you can see here, it's negative. Just take this example, okay? Take this example, so we know a number multiplied by a negative exponent is a fraction. Now that we have it clear. So we have G, the universal constant, perfectly clear. Now, what else we have? We have in the fraction, as you can see here, the unit of mass is kilogram. So we have 1 kilogram. Very good. And then the unit of the second one, another kilogram. So kilogram times kilogram. And then the radius to the square. So because it's under, it's in the fractions, is in the bottom, we know is the denominator. So we are going to put it in meter because it's the unit. And it's going to be meter square. So 1 square because go here. Now we have all the formula just written here. And we continue. We have here the final formula. As you can see here, it is, we have put all this together, following their units. We have put it all together in here. And now we are just going to operate. We can still make this bigger. We can make this bigger, and I'm going to show you how, because we have a Newton here, and we know a Newton is a kilogram meter square second. We just know it as a Newton, but the real name is Newton is kilogram meter square second. That's the real name of a Newton. This one is the real name, okay? Why? Newton is the unit of force, okay? That's why it's kilogram meter square second. Force, following the second law of Newton, is mass times acceleration, kilograms times meter square seconds. Okay, so for that reason, if we leave the Newton here alone, we can just start removing things. For example, using our knowledge of mathematics, we can see how. Meter square is fine. We don't have another one here, but for example, kilogram and kilogram is equal to kilogram square. Do we have a kilogram square in negative? Yes, this one. So goodbye. This one is gone. Very good. I have meter square. Do I have a meter square in negative? Yes, this one. So goodbye and goodbye. And what is the only thing I have? If you check, I have removed everything, and the only thing that I have is a Newton here. The rest is completely gone. The rest is gone. Meter square removed with the negative ones, kilogram square removed with the negative ones, and the only one I have free is a Newton. Why only a Newton? Because we are trying to calculate a force. And we know that if it's a force, the unit must always be Newton. So we have it here. Force must be Newton. So that's why we have, I'm going to put a lot of color here so everything is clear. It's a Newton. Things we have to keep in mind. We need to learn this. We need to learn the unit of the constant. This is the gravitational constant. And it's always the same. When it's a constant, means it never changes. The unit will always be this. And this is the unit. Okay? It has a number. The correct number of the gravitational constant is 6.67. 6.67, and now you can write like kilogram meter square seconds, kilogram meter square seconds, everything, we're gonna put it as a Newton, okay, so it's easier. Newton meter square over kilogram square. And this is the unit of, this is the constant of G. G is the gravitational constant. Remember this, it never changes. It will always be 6.67. 6.67. It cannot change. There is not a universe where you can put the gravitational constant where it's 5.57 or 5 or 4 or 3. No, it's like the number pi. It will always be 3.14. Always. There is not a universe where you can see pi as 2 or 3. No. Pi will always be 3.14. So G will always be 6.67. And with the correct unit that we have found here. So as you can see, gravitational force, universal gravitational force must be a Newton. So the result must be always kilogram meter square seconds. Kilogram meter square seconds, known as Newton. I hope you enjoyed. Please subscribe and press like. I wanted to say this. Thank you very much.